This is the Java Programmer. This is episode 3 of our Forex trading system. And today we are actually going to write some code as promised. But first off, I want to show you a little bit of a diagram to help understand how this event-driven program is going to work. And so I've put together a little diagram here. And if you notice, we are going to have kind of an elaborate setup. So on the left side, we see different methods that will generate events. So for instance, we might have a running thread that is listening for market events, news, any type of events you can think of that you want to bring into this trading system. Also rate events. So if we're hooked up to a Forex broker, we can bring in their rates as the rates change. And any other type of custom events. So Bloomberg reports or financial numbers, also like the non-farm payroll reports. Those could be events that we bring into our system. And you can see all these events get dumped into this main event queue. And I've tried to color these dots by kind of the type of event just to kind of symbolize. And I know that they are all just kind of thrown in there, but they are in a first in, first out. That's how it's going to be implemented. So it's not like they're just kind of randomly thrown in and they'll come out as they want. It is going to be first in, first out. But for my drawing's sake, I just threw some colors together. Once the queue has these events, the next thing is there's going to be a dispatcher. And so the dispatcher is going to grab items out of the queue, out of the main event queue, and then it's going to dump them into the appropriate channel queue. And so basically we're going to write, our code that we're going to write is a channel handler. So we'll have, and one handler might listen to more than one channel at a time. Just depends on how we want it to operate. But you could conceive of like an order manager that might want to listen to orders, but it also might want to listen to pricing, the rates. An account manager might want to listen to the rates as well as it might want to subscribe to orders. Or we could have a portfolio manager, database manager, which listens for the rates and then saves them off to the database so that the other managers, we could have a strategy manager, we could have a signal manager. Maybe a signal manager listens for rates and generates signals. As you can see, these managers might generate new events and put them right back into the main queue. And then you have other queues, other channel queues that are listening for signal events or whatever type of events we want to use. This is a diagram to try to explain the code that we're going to write today. The code is very minimal, but it's pretty powerful, and it is basically going to set up this infrastructure for us. And this is going to be the core of how our system runs. So events come in on the left. The dispatcher dispatches them out to the queue handlers. The queue handlers will digest the events, maybe generating new events themselves, or maybe interacting with a broker to place orders. It's just kind of up to us as we go along on how we're going to implement this. But this is going to be the core of our system. So let's finally get to writing some code. So we're back to our main class, and I want to get rid of the logging for right now. We'll come back to logging. But basically at the beginning of every class, I'm going to stick in a logger so that every class will have the ability to do some logs. But for right now, let's get rid of our hello world. We'll leave our logger in here for now, but we need to write some classes. So to keep organized, let's go ahead and we're going to create a new package. We're going to call it events. Inside of there, Eclipse doesn't like to nest these correctly. So inside of here, we're going to create a new, so under our events package, we're going to create a new class. And this class, I know we talked about events, but as an kind of a more of an abstract idea, we're going to talk about messages. And so we're going to use the term message, and then the event handler, all the event code will inherit from the message classes. So we're going to create a message interface. Let's see. Message says class. We're going to change this to interface. This is going to be pretty simple. It's going to have public class extends message interface get type. So when we have an event is going to inherit from this interface, and it's going to provide a get type method. This way, the dispatcher can distinguish between the different types of events and put them in the correct channels. So next we need to write a, I think it's the router interface, the dispatcher router, whatever you want to call it. So let's create a new interface. This can be message router interface. Takes in type E, which, oops, that doesn't go here. So interface router interface, that's going to type in E, take in a type E that extends our message interface class. And this is going to provide a couple methods. So register channel. And again, that's going to take the same type, this class that extends a message interface. That's going to be the content type. Then we're going to have a message, which we don't have this class created yet. Channel interface. Extends E, the same type. Channel. And a public abstract. So whoever inherits from this class is going to have to provide this method. So let's go ahead and create the message channel interface. And in there, it's just going to have that method, void dispatch e message. I know this is kind of theoretical. This is fairly advanced programming. For those of you that don't understand interfaces and classes and inheritance. But what this does is it basically sets up the infrastructure for our next set of classes, which are going to implement all this. Well, I didn't realize the time got away from me, so until next time, you can look for this code in GitHub. I will post the commit number, and you can download it then. Anyway, see you in the next episode.